Welcome to another deep dive. This time we're going billions of kilometers away from Earth, following the journeys of NASA's Voyager missions. It's incredible. Imagine a spacecraft launched back in the 1970s, and it's still sending back data from the edge of our solar system.
It's amazing, isn't it? A real testament to just how ambitious humans can be. Back then, reaching interstellar space was more like science fiction than reality.
And yet Voyager 1 crossed that boundary in 2012.
That's right. And Voyager 2 followed just a few years later in 2018.
So this was more than a quick trip around the block. What exactly was NASA hoping to achieve with these missions?
Well, the main objective was to take advantage of a rare opportunity. It happens only once every 175 years, a special planetary alignment.
Right.
This alignment let the Voyagers visit all four gas giants.
You mean Jupiter, Saturn, Uranus, and Neptune?
Exactly. And they did this by using this clever technique called gravity assist.
Gravity assist. I'm picturing spaceships flying through asteroid fields.
Not quite, but it is pretty ingenious. Imagine a spacecraft. It uses a planet's gravity like a slingshot to boost its speed. And it also changes direction. That's gravity assist. And it was super important for the Voyagers. It let them travel those huge distances.
That's incredible. And to think Voyager 2 is still the only spacecraft to have ever visited Uranus and Neptune.
It is.
But let's talk about the elephant in the room, the messages. The ones intended for extraterrestrial life. We're not talking about sending radio signals into space.
No, we're talking about something physical, something much more tangible.
The golden records.
Yes. Each Voyager has a 12-inch gold-plated copper disc. A golden record. Literally designed to be played like a vinyl record. It's full of information about us. About Earth, a message in a bottle for the cosmos.
So what exactly is on these golden records?
Think of it as like a sampler platter of Earth. It has 115 images. They had to encode the images into audio signals.
Wow.
But they show everything. Human anatomy, mathematical concepts, landmarks, human activities, all kinds of things.
I remember hearing about that. They even included greetings in 55 different languages. Did they really think that aliens would be able to speak Swahili or Mandarin?
Well, probably not. But it's more about representing who we are, our diversity, the incredible ways that we communicate as humans. Imagine an alien civilization finding this record, hearing all these voices from Earth.
I'm getting chills just thinking about it. What else did they put on this cosmic mixtape?
Well, no mixtape is complete without some music, so they included a selection of music from Earth. Different styles, classical, indigenous music.
So we sent Beethoven to interstellar space.
We did.
What about the rest? What else did we decide was important enough to share with potential alien life?
The last section is sounds from Earth.
Sounds.
Yeah. Like a baby crying, a kiss, animal sounds, rain, ocean waves, even a rocket launching. It's meant to capture the soundscape of our planet, all the richness and diversity of life on Earth.
They put all of that on a single record. Technology back then wasn't exactly cutting edge. How do they fit all of that on one record?
It was a challenge for sure. The Voyager's computer systems only had a storage capacity of 69 kilobytes.
69 kilobytes. That's like less than a single photo on my phone.
Exactly.
So they turned pictures into sounds.
Yep. Pretty clever, right? They projected each image onto a screen, recorded it using a TV camera. Then they converted those video signals into audio waveforms. And if an alien civilization finds it, they'll have to reverse the process to actually see the images.
So it's like a puzzle. They have to figure it out. It makes you wonder, what are the chances that any of this will ever be found?
Well, space is almost unimaginably huge. So the probability of an alien civilization finding one of the Voyagers is pretty small.
But even the smallest chance is still a chance, right?
Yeah.
The implications of finding it are astronomical. It's about more than finding some lost piece of technology. It's about connecting with another intelligent species.
You're right. It does change how we view things, doesn't it?
It does. So let's shift gears a bit here and talk about how they actually built this thing. It's easy to get caught up in the big questions, but the engineering is just as fascinating.
Oh, absolutely. We're talking about technology from the 1970s, and it's still working after all these years. In the harshness of space, it really is a testament to human ingenuity.
So what were some of the biggest challenges they had to overcome? What were the key innovations that made this journey possible?
One of the most important was the power source. They couldn't use solar panels, especially once they got past Jupiter. Sunlight is much weaker out that far. They needed something else. They needed an RTG, a radioisotope thermoelectric generator.
An RTG? I don't think I've ever seen one of those at the store. What exactly is it?
It's an amazing piece of technology. It uses the heat from the radioactive decay of plutonium to generate electricity.
Plutonium.
Yeah. It's a bit dangerous, but it's also incredibly reliable. It provides a long-lasting source of power, perfect for a mission like this.
That's fascinating. They had to invent this whole new technology just to power the spacecraft. What about communication? How did they stay in contact with Earth from billions of miles away?
That was another huge challenge. They had to equip the Voyagers with powerful transmitters and incredibly sensitive receivers to send and receive signals across such vast distances. And you have to remember, data transmission rates are incredibly slow. It's like trying to have a phone conversation, but with a delay of several hours between each sentence.
That would require some serious patience. And I imagine it's not like they have a clear line to Earth. All those signals traveling through space, there must be a lot of interference.
There is. Think of it like trying to whisper a message across a crowded room, except in this case, the room is space, full of electromagnetic noise. To get around this, they use these massive dish antennas and incredibly sophisticated signal processing. It's really a marvel of engineering.
So it's a delicate balance, raw power and clever engineering. Do they also have to think about the physical challenges of space travel?
Of course. Space is a harsh environment. Extreme temperatures, radiation, micrometeoroids, everything is trying to destroy the spacecraft. So they built the Voyagers with redundant systems, backups for critical components. If one part failed, they had a spare ready to take over.
So like a spare tire for a spaceship.
Exactly. Except in this case, the spare tire might be a backup computer or a redundant communication system. They planned for everything. Every detail was meticulously designed to ensure the mission would succeed.
Which brings us to another mind-boggling aspect of this whole thing. Navigation. How do you steer a spacecraft that's billions of kilometers away, traveling at tens of thousands of kilometers per hour?
It takes a ton of math and physics. They have to use celestial mechanics, studying the motions of planets and stars. And to plot the Voyager's courses, they had to consider the gravitational pull of every major object in the solar system, and even the subtle influences of solar radiation and the distant stars.
So like one tiny miscalculation could send the spacecraft careening off course?
That's a good way to put it. And they had to make countless course corrections along the way, each command taking hours to reach the spacecraft. It's really an incredible feat of precision and patience.
It's mind-blowing. And the coolest thing is that all the technology they developed for Voyager led to a lot of innovation we still benefit from today.
It did. Things like digital imaging and data compression. It all started with trying to send those images back from Voyager. And now we use those technologies in everything from medical imaging to our phones.
It's amazing. Voyager wasn't just about exploring space. It was about pushing the boundaries of human knowledge and inspiring future generations.
I think so. It was a catalyst for so many scientific and technological advancements. It shows what we can do when we work together.
I completely agree. We've talked about the mission, the technology, and the messages. But we can't forget the main objective, scientific discovery. What were some of the big discoveries made by the Voyager mission?
Oh, man. That's where things get really exciting. The Voyagers revealed so much, more than anyone expected. They really changed the game.
So much complexity and diversity in the outer solar system now. All right, let's start with Jupiter. Everyone's seen those iconic pictures. Jupiter's great red spot.
Right.
It's like a giant hurricane.
Yeah.
That's been going on for centuries.
Oh.
And the Voyagers gave us our first real close look at it.
They did. And they revealed those intricate patterns, all those swirling clouds. And they collected data that helped scientists understand it.
Understand how it keeps going.
Yeah.
For so long.
Yeah.
It's amazing. Something so huge and powerful. But the Great Red Spot wasn't the only thing Jupiter was hiding, was it?
Oh, no, not at all.
What else?
Well, the Voyagers discovered active volcanoes on Io,
Io?
one of Jupiter's moons.
Volcanoes, really?
Yeah, it was the first time we'd ever seen active volcanoes anywhere other than Earth.
That's wild. What did that tell us about our solar system? I mean, volcanoes on a moon.
Well, it changed our understanding of planetary geology.
Yeah.
Big time.
Right.
It showed us that these cold, distant worlds, they could still be active, geologically speaking, of course.
It's a good point. We make assumptions, and then we learn something new and have to start all over. Okay, so let's move on. What about Saturn? What did the Voyagers teach us about the ringed planet?
Oh, Saturn. Saturn was a revelation. We had pictures of the rings.
Right, yeah.
But the Voyagers, they got up close. and personal. And what they saw was stunning. Those close-ups, they showed the structure, the composition. They discovered that the rings are made up of all these icy particles.
Particles.
Countless particles. And they range in size, from tiny dust grains to some as big as houses.
Wow. I'm trying to picture flying through those rings, like navigating an obstacle course made of ice.
It would be quite a sight. The Voyagers also discovered these shepherd moons.
Shepherd moons.
Yeah, they're these small moons that orbit within the rings, and their gravity, it helps keep the rings structured. It keeps them from falling apart. It's like a dance, a celestial ballet with gravity as the choreographer.
So there's order to the rings. It's not just random debris.
Exactly. And the Voyagers, they helped us understand that order. And that's not all. They found more moons around Saturn.
More moons.
Lots of them, including Titan.
Titan.
It's a moon that's actually larger than the planet Mercury, and it's got this dense atmosphere full of organic molecules.
Titan is the one they always talk about.
Yeah.
Like a place where life could exist.
Right. It is one of the most interesting places in our solar system, that's for sure.
Methane lakes and rivers. Maybe a hidden ocean. It's incredible. Okay, we don't have much time, so let's skip ahead to Uranus and Neptune, the outer reaches of the solar system.
Yeah.
What did the Voyagers find?
Well, Uranus turned out to be a bit of an oddball. It's tilted on its side.
Tilted?
Yeah, so it's rings and moons. They orbit in a plane that's almost perpendicular to the rest of the solar system.
What? Really?
Yeah.
That must make for some interesting seasons.
To say the least. Imagine a planet where the sun doesn't set for decades and then doesn't rise for decades.
Wow.
And that wasn't the only weird thing about Uranus. The Voyagers discovered that it has a pretty complex magnetic field.
A magnetic field?
Yeah. And a ring system, too. But it's very faint. We hadn't been able to see it from Earth.
So even though it's far out, it's still dynamic and complex?
It is.
What about Neptune? What about that blue giant? What did the Voyagers teach us about Neptune?
Neptune had its own surprises, too. The Voyagers revealed a really dynamic atmosphere with powerful winds and massive storms.
Storms.
Yeah. They found one that was similar to Jupiter's Great Red Spot.
There's another one.
They called it the Great Dark Spot. But it actually disappeared later, which just shows how dynamic those planets can be.
So even though it's so far away, so cold, and so dark, there's still a lot going on.
Absolutely.
The Voyager missions really changed how we think about those planets.
They did.
It's just incredible. They collected so much data over the years. What stands out to you as the most significant contribution of the missions?
Oh, that's a tough one. The Voyager missions changed everything. How we understand gas giants, their moons, the whole outer solar system. It was a paradigm shift. But I think beyond the specific discoveries, the Voyagers are about exploration. They inspire us to push the boundaries of knowledge, to look for new horizons, and never stop asking questions about the universe and our place in it.
That's a great way to put it. It's easy to get caught up in the details, but it's that spirit of discovery that keeps us moving forward.
I agree. And the Voyagers, they're a testament to that spirit, to human ingenuity, our curiosity, and the power of exploration. They're still out there, billions of kilometers away, pushing the limits, still sending back data that's shaping our understanding of the cosmos.
And that sense of wonder, that sense of exploration is something we can all connect with. There's still so much out there waiting to be discovered.
And that's the true legacy of the Voyager missions. They gave us a glimpse of the vastness, the wonder of the universe, and inspired us to keep exploring, keep asking questions, and to keep pushing the boundaries of what we know.
We've talked about so much. The technology, those messages in a bottle.
Yeah.
But for me, it's the pictures.
The images.
Yeah, they weren't just snapshots. They were like glimpses into these alien worlds we had only dreamed of before.
It's true. The Voyagers didn't just visit those planets. They changed them. They turned them from these blurry dots of light into these real places with their own stories to tell.
And that's what I want to talk about. The stories. What were some of the most amazing moments for you?
Oh, there were so many. But I think for me, it was those first close-ups of Jupiter's Great Red Spot, to see those swirling clouds up close. It's humbling.
It's like looking into the eye of a hurricane, but a cosmic hurricane.
It is.
And we can't forget about those volcanoes on Io.
Oh, yeah. Io was a game changer.
It was. We thought moons were boring, cold, lifeless. And then, boom, volcanoes.
It really changed everything.
So what about Saturn? What wonders did the Voyagers show us about Saturn?
Saturn was incredible. Those rings, breathtaking. The Voyager showed us that they're not just a solid disk. They're made of all these tiny particles, like a giant kaleidoscope made of ice and dust.
I can't even imagine the scale, all those particles.
I know, right? And they range in size from these tiny little specks to some are as big as houses.
And they're all dancing around Saturn.
It's like a cosmic ballet.
And that's not even mentioning all the moons.
Right, so many moons.
They even found a moon bigger than Mercury, Titan, with its atmosphere and its methane lakes.
It really makes you think about the possibilities for life in the universe.
Okay, let's finish up our tour with Uranus and Neptune, those ice giants so far away. What did the Voyagers discover?
Well, Uranus was strange. It's tilted on its side like it's been knocked over, so all its rings and moons, they orbit in a different plane than the rest of the solar system.
That must make for some weird seasons.
It does. Imagine decades of sunlight followed by decades of darkness.
Wow. Anything else about Uranus?
Well, it has a magnetic field. It's pretty complex.
A magnetic field.
And a ring system, too. But it's faint.
So even way out there, Uranus is a really interesting place.
It is.
Okay, last stop. Neptune. What about the blue giant?
Neptune was dynamic. High winds, massive storms.
Really?
They even found a storm, kind of like Jupiter's Great Red Spot. They called it the Great Dark Spot. But it's gone now, which just shows these planets are always changing.
It's incredible. Even in the coldest, darkest parts of the solar system, there's still so much going on.
Exactly.
So the Voyagers changed everything, our understanding of the solar system. But what do you think their greatest legacy is?
It's hard to pick just one thing. They taught us so much about the gas giants, the moons, the rings, the whole environment out there. But beyond the discoveries themselves, they showed us what's possible when we explore.
They inspired us.
They did. They showed us that there are no limits to human ingenuity or curiosity. They pushed the boundaries of what we thought was possible and inspired generations of scientists and engineers.
And they're still going, still out there, exploring.
It's true. And even when they finally go silent, their journey will continue.
They'll keep drifting through the galaxy.
For billions of years, carrying that little piece of humanity with them.
It's an incredible thought.
It is. And maybe, someday, an alien civilization will find one. And they'll find the golden record and get a glimpse of who we were.
It's a beautiful thought. Well, as we wrap up this deep dive, I hope you've learned something new about the Voyager missions.
These amazing feats of engineering and exploration.
A testament to human curiosity, to our desire to explore the unknown. Thanks for joining us on this journey. Keep looking up and keep exploring.